Okay, I thought we would go over the quiz together and you can see how you did. In the first question, you were supposed to simplify this expression, the square root of negative 48 here. Okay, the first thing we notice here is because it's a negative number under the square root, we can rewrite that this way. I times the square root of 48. Remember, we think of I as what? The square root of negative 1. Okay? By the way, the reason why I wrote the I in front instead of afterwards is this is also acceptable. Let me show you. Technically. But you want to be careful when you write something like that, that square root, or that I doesn't migrate underneath the square root. For safety's sake, some people would do that. Okay? Okay, the square root of 48i does have a value, by the way, which is different than this. So that would be a different thing, okay? But the easiest way to do that without writing parentheses and to save yourself some ink is just write the I in front there. Anyway, so I went from here to here, okay? Now I'm going to simplify the square root of 48 as much as I can. And what I'm going to notice here is that 48 is actually 16 times 3, 16 being the largest perfect square that divides 48, I believe. Okay? Now, the square root of the product is the product of the square roots, and the square root of 16 is 4, so I'm going to let that migrate out front. So it's going to be 4i times the square root of 3. Okay? And that would probably be the best way of writing your answer here. Okay, if you saw the video on how to find powers of I, here, if you're dealing with positive powers, okay, positive integral powers of I, the way you want to do that is the following. Go ahead and take that number that you're dealing with here, the exponent that is, the power, and ignore all the digits except for the last two. And the reason why that is there'd actually be two zeros plus 21 here. Those two zeros would be 100 times 109876 times 100 plus 22. Well, 100 is divisible by 4, you see. Now, all I'm interested in is finding the remainder upon division by 4 of that number. I can ignore all those other digits then, because those are in at least the hundredths place, right? Okay? So if I've got 21, and I'm going to divide that by 4, that goes in there, what, 5 times? 5 times 4 is 20, with 1 left over. Now, the only thing I'm interested in, I don't care about that fellow. The only thing I'm interested in is what? The remainder. Okay? Now, if you did this right, you should have a remainder, which is what? 0, 1, 2, or 3, right? If you divide by 4, you should have a remainder less than 4. So in fact, this is actually equal to I to the first power. And what's I to the first power equal to? It's just plain old I. Okay? So you remember integral powers of I are either going to be what? Plus or minus 1 or plus or minus I. In this case, the answer is I. Alrighty? By the way, if you have a negative exponent in there, what you'd end up doing is just taking the conjugate of the answer here. Okay? So that would be pretty easy. If that had been I to the negative 10987621, it would be the conjugate of I, which is actually negative I. Okay? Okay. Let's look at the next question here. All right? I think most people probably did well on this one. All you have to do is basically FOIL this out like you would be multiplying any two monomials or binomials and remember that I squared is negative 1. Okay? So let's go ahead and do that. Let's go multiply with the 3 here. I'll just go from left to right. 3 times 4 is 12. 3 times 7 is 21. Don't forget there's an I sitting there as a factor also. I'm done multiplying with 3. Go with the 2i multiplies on the 4, giving us 8i. And that has a plus sign in there, right? It's actually being added there. Okay? 2 times negative 7 is negative 14. I squared, okay, because it's I times I, as you can see. But I squared is actually what? Negative 1 here. Now, if you wanted to skip a step, what you might have done is just forget about the I, even writing the I squared here, and just change the sign here to plus 14. Okay? But this is going to be 12 plus 14 because of that sign change. Okay? And then what? Plus negative 21 plus 8 because of those common factors of I there. Those are like terms. And you actually get 26. It looks like what? What's 21 minus 8? That's what? 13, and there's a negative sign on that. So this is what I got. Did you get 26 minus 13i? I hope so. Oh, by the way, I like it when you guys box in your final answers. You'll notice what that's, so I can see exactly what you're asserting. Okay? So I did that on these ones. Now, if you remember here, you're trying to find the conjugate of 2 minus 5i. Okay? To find the conjugate of a complex number, all you're doing is changing the sign on the imaginary part. The imaginary part is what? Minus 5i in this case. So you're going to change the sign on that, and it becomes 2 plus 5i. And it's as simple as that. So that's an easy question, isn't it? Okay? What would be the conjugate of minus 17? Okay? Well, you could think of that as minus 17 plus or minus 0i. And when you take the conjugate of that, you're changing the sign on the imaginary part. And you notice 0i is still 0, so it's negative 17. The conjugate of a real number is that same real number, right? Because the imaginary part is 0. You didn't change anything. Okay? This was an aside here. Okay? All right, let's go ahead and do this. There'll be one of these on the exam. You've got to find the quotient of two complex numbers. And our trick consists of writing the fraction again, but multiplying by the conjugate of the denominator over itself. Now, the conjugate of the denominator, just like the problem above, would be what? Change the sign on the imaginary part. So that would be 4 plus 3i divided by itself. That's what you have to do. So that's a fancy form of 1. 4 plus 3i divided by itself is 1. You multiply any complex number by 1, and it's unchanged. So these two are equal. Okay? Now you can see there's more work involved in this. It's like as much work as these two and more. Okay? Here you got to foil through this thing. Go 1. Just multiply numerators. 1 times 4 is 4. 1 times 3i is 3i. 2i times, 4 is positive 8i. And I'm going to skip that step here. Do you guys see how it's way what? Plus 6i squared, but I squared is negative 1. So it's actually minus 6. Now, if you followed in the book here, if you remember this, a plus bi times its conjugate, a minus bi, is actually the sum of the squares of two real numbers. And that's always going to be greater than or equal to 0. In fact, it's going to be greater than 0 whenever a plus bi are both non-zero. Okay, so this is actually 4 squared plus 3 squared. Okay, so that's a real number, positive real number. Okay, let's combine the like terms up here. We got what? Negative 2 plus 11i. Let's see, 4 squared is 16, and 9, 25. Do I leave my answer that way? The answer is no. It's not wrong, but it's not the way I want my final answer. Remember how we want our answers to look like a plus b or bi or a minus bi? Okay, so we're going to break that into the real and imaginary parts. And this will get you full credit here, so go ahead and do that. Okay, so there you go. There's our answer. All right. So there's 1 through 5. Okay. Here it is. I had that turned over. Here's a question here. Suppose I have a quadratic equation like this. ax squared plus bx plus c equals 0. A, b, and c are real numbers. And this thing I'm calling delta. Okay. Some people use different designations here. But delta is the discriminant b squared minus 4ac. Suppose that's negative. What would that tell us about the solutions? Well, remember, this comes from the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. That's our delta all over 2a. Now, remember in this case that what? Delta is less than 0. It's negative. And these are all real. So that means that what? That's pure imaginary right there, right? The square root of delta is imaginary. So then we have what? See, I could write it this way. I could bring the I out and change the sign on the delta here and divide the 2i into both of these. And you see that these are what? So negative delta is now positive. That's underneath the square root, but that would be a real number. So do you see that we've got what? Two complex solutions that are actually what? Conjugate. So we have two imaginary conjugate solutions. Okay. So that would come directly off the quadratic formula, which I hope you remember. Okay? We're going to do a couple problems down here. Let's go ahead and complete the square to solve this particular problem. Okay? You remember the first step is what? Move the constant over to the other side. So technically I do what? I subtract 8 on each side. Okay? Now the next step I would be is to divide by a the leading coefficient on both sides. See how the leading coefficient isn't written? That means it's actually 1. It's implicit, right? I'm not going to bother dividing by 1 on each side, right? That would be a waste of time. We can do it on our imagination. We get exactly what we have here. Okay, so I go to the next step. Remember the magic number is to what? To take half, once this is monic, leading coefficient is 1, take half the coefficient on x, which is negative 4, and square that. Okay, do you see that would be 4? That's the magic number you want to add to both sides of this thing. And what you should have, once you do that, when I add the 4 on each side, I think I'll go 4 minus 8. So I'll put the 4 in front of the minus 8 instead of afterwards. But you can do what you want. But the idea is this should now be a perfect square. Can you see that it's actually the square of x minus 2? And what do we have here? Negative 4. Okay? Now, what you want to do next is take the square root of each side and get rid of absolute values and all that kind of thing. So there's actually 2 of these. This would be what? Plus or minus the square root of negative 4. Okay? Now, can you see here that this is actually plus or minus 2i? Okay, that's x minus 2. Add 2 on each side to isolate the x. It's our tradition to write the real number and then the imaginary part afterwards. So we have here that x is 2 plus or minus 2i. Okay, that's completing the square. Let's use the quadratic formula. Again, it's like I had up here, right? It should be negative b plus or minus the square root of b squared minus 4ac all over 2a. I say all over 2a because both these terms are being divided by the 2a here. Now let's go ahead and stick in the numbers here. You can see that a is 1, b is negative 4, and c is 8. So we're going to have negative 4 plus or minus the square root of b squared. Okay, use parentheses around the negative 4, so you're squaring all of negative 4, minus 4ac all over 2 times 1. Okay, so that means x is actually what? 4. Let's do a little mental arithmetic. That's actually what? 16 minus 32, which is negative 16. All over 2. Okay, so that's 4 plus or minus 4i divided by 2. As I was saying before, remember that 2 is dividing both of these. So that means this. Now this is an intermediate step. that you don't necessarily have to write, but I'm doing this for emphasis here. So this is 2 plus or minus 2i. Okay, so this squares, with the answer we had in number 7. Okay, so we got the same answer in both cases. That's good. All right. Let's look at 9 here. Here in number 9, you're supposed to write this in interval notation. One thing you might do here is go ahead and just do a rough sort of graph on the real number line here. Here is 2, and I'm going to have an open dot at 2, right? Because it's x strictly less than 2, and now everything less than 2 is going to be to the left. For example, 1 1/2, 1 3/7, 0, -1. See how it's coming this way? You don't have to be too careful about it. Just make sure that you're getting everything in the right order here. The numbers get larger as you move to the right. Okay? Here, x is greater than or equal to 5. Since it's greater than or equal to 5, I want to include 5 here and everything to the right of that. Okay, so I want that to be a solid dot there. Now, what do we do with interval notation here? You start from left to right. Okay, there's no limit to the left, so that means you're going to use minus infinity. And whenever you're using plus or minus infinity, use parentheses, because you're never actually including those as real values. Okay, so we're going from minus infinity up to 2. We're not including 2, so we use parentheses. And then we've got here from 5 to infinity, right? Now, since I'm including 5, I'll use a square bracket. And again, parentheses on the positive infinity also. Now, I want those together in a single set, right? So what do? Do you remember what it was? The symbolism is sort of a U-looking thing, a smiley face without eyes. That's called union. That means to do what? What does uni mean? It means one in Latin, right? Okay? So you're making one set out of these two pieces. Okay? How about this one? Absolute value is strictly less than 9. Okay? Maybe think about the endpoints. Which two values have an absolute value equal to 9? And the answer is 9 and -9. Okay? Now those are equally spaced here, so 0's right in between them. Notice it's strictly less than 9. So what I've done here is have these open dots, right? Okay? Now it's strictly less than 9. You can think of the absolute value of x is on the real number line here, as what? The distance from the origin, the non-negative distance from the origin. Okay? So I'm taking all values of x whose distance from the origin is less than 9. Well, I could move this direction so long as I don't pass 9 this way. I will have what? A distance from the origin being strictly less than 9. Or I could move to what? I could move to the left also and come this way. And then I'd have to stop right here though, right? For example, here's 10 and here's -10. These absolute values are too large out here, right? Okay, so and anything past this, 9.1 has a absolute value which is too large. -9.01 has an absolute value which is too large. So it's actually everything between these two. So you see another way of describing this in terms of set builder notation would be what? Everything between 9 and -9. Oh, I should mention here, by the way, you'll see this in the book where I have that little vertical symbol. And sometimes people will use colons, and sometimes people will use a vertical symbol here. It's read the set, that's what the curly brackets say, of all x, it's universally quantified, such that, and then blah, 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 whatever the statement is, okay? Sometimes people use a colon, sometimes people use a vertical line here. You will see both of those. In the quiz online, I used a colon here because I already had, it was too easy to get that vertical line mixed up with absolute value and stuff here. So online, I actually did this, I believe. Okay? Alrighty. Anyways, there it is. Oh, wait. Interval notation. -9 to 9. Make those parentheses. Okay? All right, let's go ahead and solve this linear inequality here. Okay, probably the easiest way to isolate the 2x minus 3, right, is first thing, multiply on both sides by 5. And when I do that, do I change the direction of this inequality here? The answer is no. When do I change the direction of the inequality? If and only if what? I'm multiplying or dividing on both sides of the inequality by a negative number. Well, 5's not negative, so I don't change the direction of the inequality. So it's less than here and it's less than here. Okay, what's the point in doing this? Well, the 5's cancel, right? This is 5 over 1, so that cancels with the 5 down here in the denominator. Those cancel and I'm left with the numerator. That was pretty much the whole point of doing this. Now we multiply those here. Okay, now I'm going to work this like I would a simply linear equation. I'm going to add 3 on each side. You never have to worry about changing the direction of the inequality if you're adding or subtracting on both sides, right? So I'm going to add 3 on each both sides. Negative 20 plus 3 is actually negative 17. And now I'm going to divide both sides by 2. Again, do I have to worry? Nope. 2 is also positive. So x is less than negative 17 over 2. Was I supposed to write that in interval notation? I don't remember, but let's go ahead and do it. I would go from minus infinity out to what? Minus 17 halves. And since that's a strict inequality, we'll go like this. So we're saying here it's actually set of all x such that x, the set of all real x such that x is strictly less than negative 17 over 2. So this is what you should have had there. Okay, this one, some people have some questions on this type of question here. Okay, what you're trying to do is actually satisfy 2 inequalities for the same values of x, okay? So the values of x I'm looking for have to satisfy both of these. Okay, not just one of them. Has to satisfy both of them. So I connect these two with an AND statement. Now you see how easy it is. If you're dealing with these questions involving multiple inequalities, you're going to break them up into what? Single inequalities here, and you're going to connect them with an AND statement. Okay? Now go ahead and solve this one by itself. Probably the, I don't know, the easiest thing to do would maybe subtract x on each side. Okay, negative 3 is less than x, right? 2x minus x is x. Okay. How about this one? Maybe come over here. Let's go ahead and add 2x on each side. If I added 2x on each side, I would have 4x on this side and 20 on the other. Okay? I like this. At least this just has plain old x there. I don't quite like this yet because it's about 4x. The conversation's not about x like it should be. So let's go ahead and let's talk about dividing on both sides by 4. Again, 4 is positive. No need to change the direction of the inequality. Now I'm connecting these two with AND here. Okay? A lot of people can see that you could connect these two like this. Okay? So x has to be what? How would you read this? Negative 3 is less than x, and x is less than 5. That's precisely what this is saying here. Okay? Okay. I want to say a little bit more about this in the AND statement. Okay? Before I do that, let's go ahead and write this in interval notation. I probably had you do that. Okay? Just real quick here, this thing dealing with AND, I want to talk about intersection for a second here. Okay, here's the real number line, the x number line. Okay, negative 3 is less than x, so here's negative 3. Okay, now I want everything less than x. Okay, maybe I should float this above. I want negative 3 to be less than x. Another way of saying that is what? X is greater than negative 3. Okay, that would be all those values of x. Now let's say here's 5 over here. Okay, it is to the right there. Okay, and I want x to be less than 5. So it would be everything this direction. So if I was to graph these independently, that would be these two graphs respectively, you see. And now, when I connect them with an AND statement, what I want the values of x is to be common to the two. Okay? I want the value of x to be part of this set and to be part of this set. Okay? All right? Can you see what I'm actually doing here? I'm going like this. I'm intersecting the two. I'm intersecting the two. I'm finding all values of x which are common to those two, because remember, those values of x have to satisfy both of those. If I did that, where those two would overlap, by the way, do you remember that symbolism for intersection is this? Okay. All right, that's intersection. Union is a smiley face. This is a frowny face without eyes. Okay, but this would be our solution graphed on the real number line from -3 to 5 inclusive, or not inclusive. You're skipping the endpoints. So there you go. Okay. All right. Let's do 13. Okay, you have to do your arithmetic properly. There's actually two values of x whose absolute value is 17. Those two values are what? Plus 17 and minus 17. Okay? Now, there's actually two equations here. And I'm going to do this. So x satisfies this condition, or it satisfies this condition. It wouldn't be an AND statement. There is no value of x that satisfies both of these. There's no value of x that's equal to -17 and 17 at the same time, is there? Okay? Now go ahead and add 3 on each side. You get -14 here. Or add 3 on each side here, and we get 20. Now take halvesies. X is -7, or x is 10. And it wouldn't be a bad idea to go up there and double check, and you could substitute those and see that it works here. Okay, this is kind of a trick question here. Do you see I have an absolute value of something? Okay, just the 2x plus 7 is something. Don't worry about it, because I've got the absolute value of that being less than -1. Okay? Which absolute values are less than -1? The answer is there are no values I can stick in here whose absolute value will be less than -1, because absolute values are what? Always greater than or equal to 0. So I would say this: 2x plus 7 in absolute value is greater than or equal to 0 for all x. Okay, so there's no way it can be less than -1. Hence, there is no solution. Aha. So it was a trick question. No solution. Okay. Alrighty. Let's go ahead and look at this one. Most people wanted to satisfy the question by doing this, subtracting 5 on each side, -3. Okay. Alrighty. Now you can square each side. But remember, you should know from reading your book, just because the square of two things are equal doesn't mean the originals are equal. So whenever you're raising each side of an equation to an even power, you must check your answer. Because there's examples like this where you'll get what they call extraneous solutions. That is, phony solutions. They're not solutions at all, as a matter of fact. X is 9. Okay? Now, does this work? Let's go ahead and check here. Okay? Let's check. And you should have seen some examples of that from your work here. Is 5 minus the square root of 9 equal to 2? Remember, the square root of 9 is 3. It's only 3. So 5 minus 3 equals to 2. Yes. So we can come up here. This was only tentative before, right? Now we're sure it works. So you should have gotten x equals 9 here. Okay. How about this fellow? All we're interested in are what? Real solutions. Okay, I mentioned that in the quiz. What are you guys going to do? You're probably going to square each side right off. Okay? Since I'm raising each side to an even power, what do I have to do in the end? Yeah, I need to check my answers to make sure it works. Okay? Because there is examples where you get phony solutions out of these. Okay? Now if I square each side, that's what I end up getting, right? The square root disappears over here. The square of x plus 1 is x squared plus 2x plus 1. Okay? What would you do here? This is pretty easy. I would knock off those two x's on both sides probably first. And that looks pretty nice. Okay? Then maybe subtract 1 on each side. Okay? All right? The square root of x squared is the absolute value of x. It means absolute value of x is 2. That implies x is plus or minus 2, right? Okay, you didn't have to go through all this. By the way, the square root of x squared is not x. It's absolute value of x, right? You can get a sign change if x is negative, right? You could have jumped right from here to here, but I wanted to teach that little lesson. Okay, we're sure these are both solutions here? No, we're not. In fact, one of them is not a solution. Let's check x equals negative 2. And I claim this one is not a solution here. Okay? 5 plus 2 times negative 2 equal negative 2 plus 1. Okay, I'm using parentheses here to show you where I did the substitution. Okay, that's 5 plus negative 4. That's 1. Negative 2 plus 1 is negative 1. This is no. Remember, the square root of 1 is single valued. Okay, that's a contradiction. Square roots are either going to be what, imaginary, or they're going to be non-negative as such. Okay? Now, if you check x equals 2, square root of 5 plus 2 times 2 equal 2 plus 1. And you find the square root of 9 is equal to 3, and yes, it does work. So the only solution is what? X equals 2, so that's what you're going to box in as your final answer. Okay? All right, I hope you did well.